and welcome back to another video. Today we are going to do day 7 of Advent of Code. So let's jump right into it. A giant whale has decided your submarine is its next meal, and it's faster than you are. There are nowhere to run. Suddenly a swarm of crabs, each of them in their own tiny submarine, it's too deep for them otherwise, zooms to rescue you. They seem to be preparing to blast a hole in the ocean floor. Sensors indicate a massive underground cave system just beyond where they are aiming. The crab submarines need to be aligned before they can have enough power to blast a large enough hole for your submarine to get through. However, it doesn't look like they'll be aligned before the whale catches you. Maybe you can help. There is a major catch. Crab submarines can only move horizontally. You quickly make a list of the horizontal position of each crab, your puzzle input. The crab submarines have limited fuel, so you need to find a way to make them all horizontal position match while requiring them to spend as little fuel as possible. For example, consider the following horizontal positions. This means that a crab with a horizontal position of 16, a crab with a horizontal position of 1, and so on. Each change is one step in horizontal position of the crab will cost 1 fuel. So you choose the horizontal position to align them all on, but the one that costs the least fuel is horizontal position 2. This costs a total of 37 fuel. This is the cheapest possible outcome. More expensive outcomes include aligning at position 1, 41 fuel, and position 3 at 39 fuel, and position 10 at 41 fuel. Determine the horizontal position the crabs can align to use the least fuel possible. How much fuel must they spend to align to that position? Nice! So, we switch over to my code here, and I've already prepared, and these data was pretty easy today as well. So we have a bunch of data that is just positional data, so we don't need to have more than this kind of function here. So I will start with an int, let's see here, int array, numbers, and let's start with new int, and this should be test split with comma length. So that's the bunch of numbers that we want, and then we will go through here. We'll have a little iterator here, I++, and then numbers, I equals to string, s integer parse int the string. So now we need to do a bunch of things here. So we will have least fuel, and the least fuel will be integer max value. And first I think we need to figure out how many numbers, or which is the largest number. Largest number equal to 0 for int I numbers. If largest number is smaller than I, then just largest number is equal to I. So now we will have that number up there. Let's do another number here, J. Go for that. So Now we have the largest number and we have least fuel, which is max value. And then we will go through for int j equals to, let's say, k equals to 0, largest number, and k less than largest number, k plus plus, and here we will also go through all the numbers in our list with j again, and we will figure out how much fuel this will take. So k minus j, and the math absolute of that we will increase, we'll put into fuel. We'll add fuel to that, and if least fuel is larger than the fuel value, then least fuel will be equal to the fuel value, and then we will take the least fuel here and print it out. So let's see what we get if we run this function here on our test data. I've probably done something wrong here. So 37. That looks very promising because 37 was the right answer for the test data. So let's go up and do the same for the data here. And let's see what we get. We got an index out of bounds exception for length. Yeah, because I didn't change both of them. So let's do that. And we get 340,987. So let's try that and see if that's the correct result. Yes, you get a gold star, I get a gold star, everybody gets a gold star. So now to the more harder one, the number 2. The crabs don't seem interested in your proposed solution. Perhaps you misunderstand crab engineering. It turns out that crab submarine engines don't burn fuel at a constant rate. Instead, each change of 1 step in horizontal position costs 1 unit of fuel, 1 unit more than the last. The first step costs 1, the second step costs 2, the third step costs 3, and so on. Each crab moving further becomes more expensive. This changes the best horizontal position to align them all. In this example above becomes 5, okay? And this will cost 168 fuel. This is the new cheapest position outcome to the old alignment of 2, costing 206 instead. Determine the horizontal position the crabs can align to use the least fuel possible so they can make the escape route. How much fuel must they spend to align to that position? Okay, so let's see here. In order to figure this one out, we need to have this kind of permutation thingy. So 1 unit for 1, 2 for the second step cost 2. So 5 would be 5, 4, 3, 1, and so on. Yeah. So then we will switch back to our test data here. And here, instead of this, we need to have number of steps like that, and steps permutation Java. Let's see if we have an easy way to do that. So this is times. I don't remember what it's called. When you have 3 plus 2 plus 1. I really don't want to make this this kind of a thing where you need to calculate each step each time. How can we make this simpler? Perhaps we can take the largest number and pre-calculate some stuff here. Permute map. I think there must be a better way to do this. The largest number, 0 to the largest number, I plus plus. Let's do like that. And then permute map is equal to this P and then the val, and val is equal to 0 of this for loop here where we have int t. Let's do a bunch of this bad coding. So t up to p, t plus plus, like that. And we need to have p as well, so we need to add that as well. So val is equal to that. So now we can have number of steps, permute map, get steps. That is what we will add here. So we change to test and see if we get the right number here. Null pointer exception. The object is null. So that's no good. Largest number plus 1. 168, which is the right value. So what I did here is that I created this map where I put in all the numbers so I could look up how many steps is needed. So I don't need to calculate that each time. So I go through here and create this permutation with 1 plus 2 plus 3 plus 4 until the number that I want to have, just to do some pre-calculation. Hopefully that will help us in the speed of this thing, so it don't take forever to run. So the value would be, let's see here, 96,987,874. So let's see if that is the right value. Yes, you get a gold star, I get a gold star, everybody gets a gold star. So this was day 7. I perhaps not made the most beautiful solution here, but at least it was correct, and that's the most important part. figuring it out and making a solution that works each day. I hope that you found this interesting. I hope that you learned something today. If you like this video, give it a like, share it with your friends and colleagues. If you figured out this permutation thing and how to solve that in Java, please give me a comment down below on how to actually solve that. And if you haven't subscribed yet, please do that. And I really hope to see you in the next video.